Very good morning, everyone. Warm greetings to one and all who have joined here. It gives me immense pleasure to welcome you all to day two of the virtual faculty development program on cyber physical system, organized by the Department of Information Technology, M.G.R University. Technology is the best when it brings people together. Indeed, this FDP is vibrant platform for academic minds converge to explore the realm of intelligent systems, cyber physical systems, or integration of computation, networking, and physical processes. These systems are the cornerstone of the innovations like smart healthcare, intelligent transportation, Industry 4.0, and autonomous systems. Over the next 4 days, we are going to explore more about the cyber physical system with the help of our knowledgeable and experienced resource persons. To formally set the tone for this event, I now invite Dr.N.Kanya, Head of the Department of Information Technology, to deliver the welcome address. Welcome you, ma'am.
Thank you. Thank you, Shilpa. Respected dignitaries, esteemed faculty members, and dear participants. It's with a great pleasure to welcome you all to the second day of our 5 days virtual faculty development program on cyber physical system, organized by Department of Information Technology and Center of Excellence in Cyber Physical Systems of Dr. M.G.R. Educational Research Institute. First and foremost, we extend our heartfelt gratitude to our esteemed leader and our founder chancellor, Dr. A.C. Shanmugam sir, and our president engineer A.C. Kumar sir, for the continuous support and encouragement. We are honored to have Dr. V.Cyril Raj, additional registrar of Dr. M.G.R. Educational Research Institute today. Welcome you, sir.
Yes,
Sir's vast knowledge and experience will surely provide us with valuable insight. I'm happy to welcome today's speaker, Dr.A.Vadivel from Gitam University. Welcome you, sir. He's going to deliver on the topic communication and networking in CPS. I'm happy to welcome all the participants who have joined us through the digital media. Welcome you all to this second day of FDP. Kindly maintain the digital ethics. Stay tuned to learn. Thank you.
Kanya madam, is my connectivity is correct? Actually,
Yes, sir. This audio is clear, sir.
I'm getting a lot of disconnect.
Okay, the audio is clear, sir. Sometimes it's going, sir.
Thank you, ma'am.
Okay.
Now, in between, there is a lag, sir.
Okay.
Thank you, ma'am. Thank you, ma'am, for your wonderful words. To grace this occasion, we are honored to have our respected additional registrar, Mr. Professor Dr. Cyril Raj, sir, with us. Now, I humbly invite you, sir, to deliver the felicitation address.
Sir?
The most who has readily accepted the invite from the Information Technology Department of our university, supposed to be one of the vibrant department in the Faculty of Engineering Technology. Happy to see that they are organizing a virtual FDP program on cyber physical systems. Dear faculty friends, you're aware how the Industry 4.0 is trying to command. I'll say how it is creating a havoc with respect to the industry automation. So all the things are happening because of that cyber physical systems, where the process and then the control of the process and then communication to the process. All these things has to seamlessly integrated, or it should happen also. I think during our days we have studied the real-time operating systems, RTAs, and then where the industry automations were implemented. But now the phase of the industry automation has gone into, unimaginable, dimensions also, where during the process normally, where we used to observe the outcome of the process, and then we used to take the feedback, and then manually we have to correct all the things, and then we have to do with the mathematics and then the science behind that particular process, and then how to control the process. So it had taken a lot of time, but right now with all the integration of AI, and then again, there is a seamless optimization in the production process is happening, either with the intervention of human, or with the intervention of artificial intelligence. All these things are happening there. So definitely, dear friends, this cyber physical system is, I'll say, the heart of that industry 4.0. Right now, we are, again, meddling with the Academy 5.0 also, where finally, after making a lot of turns, then now we are coming back to the classroom teaching. Definitely, a teacher cannot be replaced by any of the other entities that actually the human have created also. But as far as this particular cyber physical system is concerned, okay, a lot of factors are, helping the cyber physical systems, like the seamless connectivity, where right now we have the 5G network, where the latency is in terms of only 1 millisecond. So the 1 millisecond is really sufficient, latency to take the cognizance of, what is happening there in the real-time process. Either it could be an autonomous car, or a physician, remotely sitting and then doing a robotic surgery there in other part of the world, or say, when a huge automated industry, being controlled by a knowledge-based system. All these things, nuclear, are possible with 1 millisecond of latency. But at the same time, we have one more potent weapon with us, that is the Internet of Things, with IPv6. So, dear friends, I think you are aware, we have already exhausted the IPv4 addressing space of 32 bits. Now, with the IPv6, we could able to expand it with 128-bit addressing scheme, where each one of us, nuclear, we can get around 2.3 into 10 to the power of 6 number of V6 address space. So that means that there are the scope of that industrialization, that too optimization. All these things are really, enormous. With the with all these developments. So, dear friends, we have to have a multi-pronged approach towards the cyber physical systems, where the associated the knowledge, as already told you, should also be considered with appropriate clear understanding of the controls, real-time control systems. All these things, nuclear, will definitely do a lot of changes in the way the things are being manufactured or being processed, especially for autonomous activities. I think, dear friends, you are aware, in most of the northern Europe, that even 1,000 cow milk plant, nuclear, are managed only by few human interventions also. If you go through the YouTube videos, you can see many amazing such industrial automation things which are happening there. just because of that cyber physical systems. And then right now, even in the defense also, difference, I think you may be knowing it very recently, China has demonstrated a drone-based, firework on the sky. Amazing. Around 4,000 drones were coherently talking to each other on the real-time basis, and then aligning, and then controlling the firing of the crackers. Such a beautiful thing. The same thing is going to happen there with the defense also. The drones together targeting the various key installations of an enemy country. So many developments are going to happen in this particular domain. But at the same time, if you see that the business opportunities in this CPS by 2026, government. Predicts total outlay of around yet to happen there in this particular domain. So, dear friends, so let us take this CPS as a very serious topic, and then we'll have train our students as a better CPS enabled students for the development of our country. So with this, once again, let me thank Dr.Kanya and then her team for choosing such a very important topic for the faculty development program. Thanks a lot.
Thank you, sir, for your encouraging and inspiring words. Your vision continues to guide us towards academic excellence. Now, let me quickly brief the guidelines for the participants. The FDP is between 10 a.m. to 12 p.m. for all the upcoming days till Friday, May 30th. Feedback link will be shared towards the end of the session here in the Zoom. It will be active for 20 minutes. It is the participants' responsibility to stay connected till the end. It will not be shared in the WhatsApp group or by email. All the candidates have registered for the FDP or not eligible for certification. E-certificates will be provided only for active participants based on attendance taken automatically by Zoom and feedback form submission. Post your queries in chat box. It will be answered towards the end of question and answer session. Please avoid unnecessary discussion in the chat box. Thank you. Now, I call upon Mrs. Sharmila to introduce our Honorable Chief Guest.
Dr.A.Vadivel is a professor and head of the Department of Artificial Intelligence and Data Science at Gitam University, Bengaluru. He earned his PhD in Computer Science and Engineering from IIT Kharagpur and brings over 25 years of experience as an educator, researcher, and academic leader, having served in reputed institutions like NIT Trichy, SRM University, and ICFAI Hyderabad. His area of expertise include artificial intelligence, multimedia information retrieval, object tracking, and medical image analysis. He has published widely in top-tier journals, guided numerous research scholars, and led several government-funded projects. Dr. Vadivel is also a recipient of prestigious awards like the Indo-US Research Fellowship and has been trained at globally renowned institutions such as MIT and UC Berkeley. With his remarkable academic journey, innovative mindset, and inspiring leadership, he continued to shape the future of data science and AI education in India. Let us give a warm and enthusiastic welcome to a visionary educator and researcher, Dr.A.Vadivel.
Thank you so much, Shamila ma'am. We now call Sir Chief Guest Sir Vadivel sir to take over the session.
Thanks, madam. I would like to share the screen, ma'am.
Yes, sir. 1 second, sir.
Make me co-host so that.
Yes, sir. It's been done, sir. You have been
It's done?
Yes.
Yeah. Whether my screen is visible?
Yes, sir. It's visible, sir.
It's visible, yeah. Is it moving?
Yes, sir. Yes, it's moving.
Slides are progressing?
Yes, sir. Yes, yes, it is.
Yeah. Good morning, my dear friends, and I thank the organizing team for giving me a wonderful opportunity to interact with the faculty friends from various institutions and universities. Maybe I'll be trying to entertain you for the next 1.5 hours. Even taking the discussion offline is challenging, and online is more challenging, as you know, as a teacher. I don't see your face. You don't see my face, but still we, interact with each other, believing that, you watch me and I watch you. As per the FDP's criteria, you are asked to submit the queries, and then I'll take it up at the end of the session and answer your query as far as possible. So don't hesitate to put on a lot of queries. Maybe we can have a larger buffer of time for question and answering. We can eventually reduce the recitation so that it is becoming effective. So let us start. The topic of discussion for today session is networking and communication in CPS. Since the FDP has started yesterday, I believe you have understood the fundamentals, concepts of the cyber physical systems, and this is one of the important research area, and it is becoming a course of the computer science and engineering and AI and data science discipline. Or for the matter of fact, you take any discipline, now CPS is becoming part of that. It connects industry 5.0, it connects any engineering discipline or manufacturing discipline. So with this introduction, let me move forward. Formally, the definition of CPS as far as NFS, National Science Foundations, is concerned, the cyber physical system, in short you call it as CPS, is built from the engineering system. As the assistant registrar sir was introducing the session, he was talking about industry 4.0 and the manufacturing industry, etc., etc. Once you go deep into these details, you'll see that there are a lot of engineering systems. So CPS is essentially a form of engineering system, right? And then it has a kind of, the methodology to seamlessly integrate the computation and physical components. Most of you know that the CPS encompasses the engineering system in the sense that the computation, communication, etc., etc., and also the physical components. What is the physical component that we are talking about? The physical component is actuators, sensors, or you can slightly modify and say it is IoT devices or IIoT devices, meaning that industrial, the Internet of Things. So when you see from the top, you call it as aerial view. The CPS is nothing but the interconnection of the engineering devices and the physical components, where the computation is also happening along with the networking system. So this is how the cyber physical systems are realized. I mean, as far as the National Science Foundation is concerned. Now, the cyber physical system, it was into the picture in 2020s, and then it is increasing day by day in all the computer science domain. Now, what are all the advances that is happening in CPS is capability. What do you mean by capability? In the sense that what CPS can do, is there a capability defined? You will be wondering to see that the CPS has become pervasive. Means we always say that God is pervasive. Now CPS has become pervasive. Why? Without CPS, you cannot have any engineering system at all. If you want to develop anything, the bottom line should be security, right? And without CPS, you cannot realize that. So the capability of CPS is, enlarging its scope in all the discipline across. You take manufacturing, you take mechanical, you take software defined vehicle, you take drone technologies, you take robotics, anything you take without CPS, wherever there is a physical system involved, the CPS is important. So the capability of CPS is more and its scope is very high. And it should be also adaptable in the sense that now the concept is becoming plug and play. You have a system, and then system should be just you should plug in wherever you want, and then it should play. That is how the things are happening. So it is a kind of adaptability as far as NFS definition is concerned. Scalability. Now you are giving CPS concept or CPS infrastructure for say 100 devices, 100 physical devices. Can it be enlarged? Can it be scaled up? Can it be scaled down? If I scale up, what is going to happen to the CPS capability? If I scale up, what is going to happen to this, the capability? So it is not just like that you can do. There is a kind of, algorithmic approach in scalability as well. Similarly, resiliency, safety, security, and usability. So likewise, you can keep on talk about all these, the advancement for, hours together. But for want of time, I just gave, kind of introductory explanation to some of the terms, and others are self-explanatory. Safety is known to us. What is the safety protocols? Security that we are talking about. Usability. Are we going to really use? So if your system is so complex and if it is not user friendly, none of the industry will use your the CPS systems. So likewise, the advances in CPS will enable the capability of the physical infrastructure, adaptability, scalability, resiliency, safety of the systems, security of the system, and usability of the systems. So these are all the horizons where the CPS is going to expand. And so after having all these, as far as NFS is concerned, the CPS technologies is going to transform the way the people interact with the engineering systems. So how are you, say for example, ATM is an engineering system. You may not know what is the engineering that is happening in, behind. And if you are sitting in a cruise, it is basically an engineering system. You sit in a car, it's an engineering system. You ride a bike, it's an engineering system. So how the CPS technologies are transforming, the way people think about the engineering system is really, going to be a wonder. Okay. So now actually, I would like to talk about two technologies in deep because I myself involved. We have in Gitam a research infrastructure called Murthy Research Infrastructure, where I'm involved in. I mean, I'm the lab lead of the drone technologies lab, as well as I'm also associated with the software defined vehicle. So before really we get into the technical aspect, I will talk about the engineering aspect and the physical aspect of these systems, and then I'll tell you how the CPS will make the communication networking such that these systems are safe. See, these systems are secure, right? All of us know the drones. Even your assistant registrar sir was talking about the drones. That is called orchestration of the drone for a particular task. You will have many number of drones, and then they communicate each other that at a point of time t, what is the task should be carried out. So similarly, in the system that we have the Sindoor, the recent Sindoor against the Pahalgam attack, you might have heard about the drones from Turkey. Most of the drones from Turkey have come to our the territory, and then we have handled it. So what is happening here is that the expansion of drone technologies is the large, and it is becoming omnipresent. Now people started using it to the defense application. As you know, the drone in general called as unmanned aerial vehicle, and whenever there is an unmanned aerial vehicle, the communication is wireless. Most of the time, predominantly it is wireless. If it is wireless, you will say that there is a frequency involved. But unfortunately or fortunately, the frequency that are allotted to the drones is 2.4 gigahertz. That is the scientific, the bandwidth, the free bandwidth. So what will happen? Anyone can intercept. So when you use it for the, defense application, the signal that is, propagating from the drone and then the transmitter, and if there is someone who can intercept, I mean, I'm talking about the communication aspects so that you can understand. Now, have a look at this. How do I hide this? Record, enable, hide names and annotations. Yeah. Now have a look at this. Am I audible? Am I audible? Hi, participants. Yeah. Okay, that's fine. Thanks, Dr. Tenmuri. Now have a look at this. This is the drone. Now, you have the spoofed signal. See here, my mouse, you can have a look at my mouse. It is a spoofed signals. And I have malware and the Trojan, right? Then I have the jamming signal problem, then malicious communication, spoofed signals. Then I also have the hardware Trojans. Now you can see that since I am working on this field, I can talk, on very, the deep, but I don't want to go deep. I'll be deviating from um, um, the cyber physical system aspect. So I'll concentrate only on the cyber physical system aspect. Now, this is the controller. In general, all the unmanned aerial vehicle will have the control here. Then you have the signal which is communicating or propagating from controller to the drone. And then you have a satellite. From there, you get the GPS signal because you need to have the location, right? Now, what can happen is that anyone can hack because the signal or the frequency, the medium is 2.4 gigahertz, or people have changed to now 4.8. But all these frequencies are known already. And people can do the spoofed signal. You know what is spoofed signal in the sense that as if the signal is from myself. And I can do the jamming signal. Once I do the jamming signal, this fellow will be blinking where to go and how to go, kind of thing. I can manipulate the control signals, right? So in all these aspect, the communication, that is what we are going to talk about. The communication and the networking aspect of this is going to be very, very, tough as far as CPS is concerned. As far as normal communication, the normal networking is concerned, it is very easy. I enable my GPS, I trigger my control, I have my geofencing, I give the coordinates, it flies. I give the thrust, it flies. And then come back to the original place and as per my configuration, as per my this thing. But this is the conventional way. But if I want to use the cyber concept, the CPS concept, the communication networking aspect is going to be very, very different. We'll discuss why. You please have a look at this picture carefully and then throw the questions in the text, okay, in the chat box. We'll come back to this and then I'll address your query so that it is narrowed down and then it is useful to you. Please push a lot of questions. I'll make a pause here for 30 seconds, have a look at this picture, and then push a lot of questions in the chat box, and then we'll come back at the end of the session so that I can, address your queries and concerns. So 30 seconds break for this. All the participants, push your questions in the chat box. Yeah, I'm sorry. Yeah, 30 seconds is over. Now let us go to the another one. This is also very, very popular research topic in recent times. This is called software defined vehicle. Tesla is the popular software defined vehicle. In India, Mahindra has come up with a software defined vehicle. It is called 9E and then 6E. These two are very, using the concept of software defined vehicle in the sense that most of the body parts or the frames of the car is embedded with the sensors. So what do you mean by sensor? Sensor is basically a physical system that interact with the physical world, the real-time world. Now have a look at this. If you think an automobile just like that, you will just say that okay, there is a wheel, there is an engine. I mean, if ICE engine or the electric motor, gearbox, If it is electric motor, there is no gearbox, accelerator. These are the very conventional way of talking about this. You might have seen in some of the English movies that the cars are hijacked. Now, the software-defined vehicle is the one where if I want, I can control your car when you are in the driver's seat. That is how the system is going. Now, have a look at this. All these points, keyless spoofing attack key certificates, SV charger attacks. Actually, this is the first place where your car is going to be attacked. The moment where you are going for charging your car in the commercial outlet, you are giving the physical connectivity of it's called charging gun. If you insert, that is the first place you are going to attack. Okay. And then EV charger, sniffing, man in the middle. So likewise, I have given around 10 to 15 kinds of attacks that is possible in the software defined vehicle, and this is going to be the future. Now the automobile industry is getting, moving towards software defined vehicle, industry 4 and industry 5. The manufacturing concept of automobile is also redefined. People are talking about batteries, people are talking about charger, people are talking about more of computer science rather than mechanical engineering and automobile engineering. So here also, I'm giving you 30 seconds time. Please push your queries on this, especially the security aspect, the CPS systems, software defined vehicle, computer science, AI, mixed. You push your queries in the chat box. Then we'll come back after finishing the slide. Then we will discuss in detail so that you understand much. 30 seconds. Please push your queries in the chat box. I'm not getting any questions. Please push. You should push. Yeah, Tenmur, you want to say something? Okay. 30 seconds is over. Now let us go forward. Yeah. So now we are into the technical part of the CPS. Before getting into the communication aspect of this, I would like to, give little foundation so that you understand what I am talking about. So when you talk about any physical system, as I said, it is popped in 2006 and then coined by Helen Gill at National Science Foundation. That is what I was talking about. Now have a look at this picture. So you have Subhash, I'm in a meeting. I'll call you. I'm sorry. So have a look at this. There is a physical plant. Physical plant in the sense it can be anything. Okay, it can be anything. And then you have the physical interface. Physical interface is in terms of the actuators, sensors, IoT devices, or anything that senses the real world, right? Now, the yellow color is having a sensor part and then computation part. And similarly here you have sensor part and then computation part. Then you have an activator. The activator merges all the computation, communication, etc., together, and then it is giving to the activator. And then activator is, going to the physical plant, and then physical interface is going to the sensor. It is basically a loop. Those who understand electronics, they will say the feedback system. You will see that this is a feedback system kind of thing. In the back side, you have a network fabric, and this is where we are going to concentrate more. So the platform 1 and platform 2 are going to communicate each other. And each and every platform is having computation and sensor. And all the computation and sensor, is merged and then fed to the activator, and then it goes to the physical infrastructure. So most of the, the cyber physical system infrastructure is modeled like this. And as you know, the network fabric is talking about is the one which enables the communication between the platform 1 and then platform 2. How do you communicate? As of now, assume that there is no CPS requirement, then you will say that I will communicate as regular as possible. Say no encryption, no decryption, no control, no security aspects, no protocols, nothing. Very simple, the plain kind of thing. But when you are talking about the cyber physical system, the computation happens here, will adapt to the cyber physical system concept. Similarly, the sensors activators will adapt to the cyber physical system. And also the network fabric, which is over which the communication happens, need to adapt to the protocols that are, needs to be adapted for the cyber physical system, right? So this is the kind of, the framework, open framework, or the bottom line on which everything is built, right? Now, there are a lot of applications of the CPS. Without CPS now, none of the applications. Agricultural, say precision agriculture is very much on the way. Most of the agricultural university or entire India is driving towards the agriculture, where the precision agriculture, etc., uses a lot of sensors, and these sensor values are very crucial, and then you need to save them from the cyber attack. So where you'll find it is a cyber physical system that handles the sensor values. I mean, it is nothing but the activators, etc. Aeronautics, yes, you have a lot of cyber physical system applications. Building design, maybe I can take 1 or 2 minutes extra here. Building design and then civil infrastructure. I have recently visited CBIR, I mean Central Building Research Institute in Roorkee, which is a central government institute, and they are the one who come up with the specification of concrete, specification of pillars, specification of columns, specification of road over bridge. For entire India, they are the one. For your information, they are the one. They made, the tilak using sunlight for Ram Leela in Ayodhya. I mean, they made a kind of, the civil infrastructure with a little bit mechanical and automation. So I visited there. You will be wondering to see a 3D printing is there for concrete. Okay, you need have to really scratch your head for your roof. You put the concrete and then use the 3D print. It prints and then gives. And there are a lot of automations. Say each and every building, each and every column, each and every roof are planted with sensors, and each and every sensor is communicating with all, the activators, etc. The sensors are connected to only one fiber, and one fiber is communicating to all the sensors. It is really kind of wonder how one fiber will take care of all the signal. Then they, modulate the signal of each and every sensor using one fiber. It's a wonderful infrastructure. Bottom line is all the signal that are coming in the communication network they form is under CPS, right? Very, very interesting applications. Energy, environmental quality, healthcare and personalized medicine, very, very useful, because lot of privacy is required as far as healthcare and personalized medicine is concerned. I don't want to reveal that what kind of prescription I have for my disease. I mean, it is so privacy to me. So most of the hospitals are having, the controlled access of data. It's all under CPS infrastructure. Manufacturing, there is a concept now called digital twin. Any manufacturing that is happening, so initially there is a software mimic of the real hardware, and then whatever you do in the software, it should happen in the hardware. It is called digital twin technologies, penetrated to the manufacturing, transportation, the software defined vehicle. Okay, so here also you can pump in one or two queries in the chat box. We'll come back and then discuss if you have any specific queries. Now, whatever I said, you can see, say energy, the wind tunnel. I can hack the wind tunnel by sitting anywhere. How do I handle it? Avionics, a lot of simulation, lot of digital twin aspect is happening in avionics. Military, I told you already, there are drones, which is participating in military operations, and the Italy is the one which is, Iron Dome is their safety cover to Italy, not Italy, which country? And it has been broken by the group called Palestinian group, right? So it is 2.4 gigahertz and 4.8 gigahertz open frequencies, buildings, manufacturing, automotive. So in all these, you will have cyber physical, computation plus dynamics plus communication, security, safety. So all these put together, you will have the cyber physical system, right? Yeah. So automotive, this thing, people talk about the software defined vehicle, safe transportation, smart transportation, energy efficient, climate change, human robot collaboration. So in all these, you'll see that the automotive CPS, it is called automotive CPS. In software defined vehicle, one of the areas in which the automotive CPS is another area, sub area where it takes care of entire, the safety of the vehicle, right? So here you will see that, the one which is having the red color and blue color combination of this is called circuits, where you will see that streamlined the data transfer, the secured data transfer for controlling even the clutch pedal signal, the accelerator signal. Anyway, clutch may not be there. Accelerator, seat belt, the activities of human. So likewise, everything is passed in a secured manner. We'll see this later when you this thing. Yeah, this is one of the drones that these kind of drones we have. So I thought I'll show this. And this fellow is quadrupter in the sense that you will have 4 propeller, right? And then the last one is the frame that safeguard the propeller even if it falls. I mean, because doing R&D time, I myself broken a lot of propellers, right? So this is the guard kind of thing. Though this is called Smart Mac quadrotor, or you can say quadcopter aircraft, right? Now, have a look at this. Take 30 seconds. Take 30 seconds, because I saw some of the queries. What is the encryption mechanisms, etc., etc. Push in a lot of questions. Put in a lot of questions in the chat box. This is related to the quadcopter that I have shown, and this is related to the communication aspects of the quadcopter, the system, controller, and other devices, other components. Have 30 seconds, note down some queries, push it to the chat box. Okay. Yes. Have a look at this. Let us start from one. Say, I am here. My mouse is on the robo stick. Okay, robo sticks. So this is the low level control. Low level control. And another one is, it's a kind of, small system, a supervisor you can call. Then another yellow color is a system. I mean, kind of system. So all these are a kind of, the high level system that is going to control all small components that are used for manufacturing or combining or assembling a particular quadcopter drone. Now see what is the communication that is happening. Since we need to concentrate more on the network aspect and then communication aspect in CPS, have a look at this LiDAR. LiDAR is very, very popular and one of the important system. It's a kind of radar used in drones as well as the software defined vehicles. The communication is RS-232C, right? And then the speed at which it can communicate is 115 kbps. Because it is internal communication. You may be thinking it is very thing, but it's not possible. Then stereo cam. I mean, most of the drones or any of the system that come will have the cameras with the 30 frames per second of size. I mean, this is 320 and 240 is the frame size. And this is communicating with the system and it is firewire. Firewire means it's a kind of fast one. 480 Mbps, that's a fast one, firewire, right? So this is the speed at which the communication is happening. The GPS, IMU, see this is universal asynchronous, the transmitter. UART is known to all of us. In all of the cases, IMU, GPS, right, the robo sticks, all these fellows are communicating in UART. And this is also communicating in UART, right? Now, UART is communicating this rectangle is a bus, UART bus. Now you see the way in which it is communicating. Come on the right hand side, Wi-Fi 802.11g. Okay, less than 54 Mbps. Then here it is 8011.b, less than 5 Mbps. You know that if you go towards, because 802.11 has gone up to N, A, B, C, D, F, G, H, I, J, K, L, M, N under research. So when G is on the higher side, B, so it is less than 5 Mbps. This you can see that it is also using USB. This fellow uses CF and the communication aspect and then computation aspects. So whole business put together, this is the engineering system with communication. The communication is happening with different protocols. Okay, 802.11g is a protocol, 802.11b is a protocol, RS-232C is a protocol, UART is a protocol, right? Firewire is a protocol. Likewise, PPM is a protocol. Likewise, all these communication is happening and computation is also happening. Now, if it happens in the conventional way, you think of the drone that you develop and then you deploy it for the defense application, it is gone. Not only for the defense application, even for academic and research purpose, you don't safeguard, then there is a collusion, gone. The entire, the design is waste. So likewise, there are so many aspects that is happening in the CPS system. This is a CPS system. I've taken out the drone component. I am talking about the engineering component that are connected using the various protocols, using different, the communication system, communication medium, and then the network interfaces, right? Please push in a lot of questions on this and then we'll come back to this. Yeah, now the core concept. As you know that any of the network systems or communication systems Either it is a plain, the TCP suite or OSI model or the conventional Wi-Fi system that you use, all the systems should have a communication system, the layers. Have a look at this. Most of the computer science faculty are familiar with this. One is the application layer, network layer, and then the physical layer. It is in contrast to the TCP IP suite that we use. The TCP IP suite uses 5 layers. OSI model uses 7 layers. But here it is, composed of 3 layers. So physical layers, network layer, and application layer. My gut feeling is that all the computer science faculty will have the function of each and every layer in the TCP IP suite. All of you, because it is a favorite course for all the faculty. Physical layer, it has all, the sensors, activators, etc., etc. Network layer, you will have protocols like, routing protocols. Application layer, you will have a lot of application protocols. Now, when you come to the CPS system, the entire paradigm changes. What is that? I'm sorry. What is that? So in physical layer, what all can happen as far as CPS is concerned? You can have jamming. You can have compromised key attack. You can have false data injection. You can have eavesdropping. This is minimal. The minimal, the cyber related attacks I'm talking about. Right? So what you should do as a CPS guy, when you define the physical layer and the corresponding protocols, the system should handle at least these protocols. You should handle eavesdropping. You should handle jamming. You should handle compromised key attack. You should handle false data injection. And that is how the engineering application of the CPS system will evolve. Then, as you know, from the physical layer, the signal moves to the network layer. Middleman attack, middle of the man attack, MITM. Then the denial of service attack, that can happen in the network layer. So the entire protocol defined should be changed to the CPS architecture. It is not the conventional way of you define the network layer only with, the conventional IP, TCP IP, etc., etc. You need more. And similarly, when you go to the application layer, what all you can have? The possible attacks. Malicious code you can have, sniffing, access control, the data theft. So whatever protocol you design or you develop should handle at least these threats. Then only you can have the perfect layers of communication system as far as CPS is concerned. Otherwise, it is going to be the conventional. So given this scenario, let us see what all will happen in these layers so that as a teacher you come to know and then you can deliver the aspect to the students. So key aspects of the application layer, we are talking about the application layer in terms of CPS. Please remember that we are not talking in terms of TCP IP suite and we are not talking in terms of the OSI model. So as you know, this fellow facilitates the communication. It provides the framework for various applications that you deploy in the application layer. Say, for example, the control algorithms, monitoring softwares, or any of the protocol that you use. And then all these, since the communication is facilitated, it is facilitated among various applications, okay, in the physical world. Then it also handles the data exchange, okay. So whenever there is a softwares or application, you see that the data is exchanged between various components. Here we refer the CPS components. Say, for example, sensor readings, control commands, and then a system status information. So these are all input consumed by the application in the application layers in terms of data exchange is concerned. Then a suitable protocol selection depending upon the application you choose. Say, for example, The conventional, you had TCP, sorry, HTTP, FTP, etc., etc. Similarly here, this fellow, I mean, the CPS environment handles the protocol which is reliable, having low latency, and which attains the security requirements as well, right? Some more aspects. So what is going to happen in the physical layer is, as you know, the physical layer is full of hardware, sensor, activators, wire, frames, connector, etc., etc. But application layer is full of softwares. If you open the application, you see application layer, you see it will be the abstraction of entire hardware and then the software that is available in the hardware layer. So it encapsulates the entire hardware and then shows as a kind of the soft touch, and that is one of the key aspects of the application layer. Say for example, the wireless communication, how is it going to happen? The wired business, how is it going to happen? The connector, what is the type of connector? These are all modeled in the software available in the application layer, but it is the abstraction of the physical layer. And then control and management is also one of the key aspects of the application layer. It enables the control and management of the CPS so that the users and the system can access seamlessly with the physical process or whatever is the the task defined. Now, example of the application protocol in CPS. I told you that this is not the conventional TCP/IP suite, so the protocol will be different. So you have a protocol called MQTT, message queuing, telemetry transport. Telemetry transport is very popular in drone technologies and software-defined vehicle, or some of the sensors. Wherever you have sensors with camera, these, that, and all, you will find the telemetry data. People call it as telemetry data. So it is a lightweight protocol because telemetry data means, it uses the wire, tele in the sense that wireless kind of thing most of the time. So it is a lightweight, so enabling the very fast and reliable communication. Then you also have a protocol, constrained application protocol, called a COAP. This is for constrained devices in IoT. Say some of the devices will have low power but need to send the data continuously. So these are all, and some of the sensors which are planted in hill stations and wherever man is not available, not accessible, those are all controlled constrained application protocol. I mean the devices where the COAP is used. Then DDS, data distribution service. This is also a real-time protocol for data sharing. It's commonly used in robotics and automated vehicles. Say this thing, a continuous streaming is required. Okay, real-time kind of thing, right? So when robo is moving left, right, straight, so continuous feedback is required. So you have DDS in application layer to support this. And you also have the OPC UA. It is basically OPC Unified Architecture Protocol. It is for data exchange and control, especially for industrial automation systems. And it handles the interoperability. It is manufacturing. I mean, it can be device can be manufactured by any of the manufacturer, but you can connect it through these protocols so that seamless interoperability is handled. Then HTTP you have, HTTP, HTTPS. Most of the systems are web controlled, web enabled. So you have this, you know the purpose of this protocol, so I need not to explain you much. And similarly, you have the network layer functions. The network layer function, as you see, maybe I can go back and then show. Say network layer is, it is acting as the sandwich between the application layer and then physical layer. Most of the computer science faculty will definitely understand how things will happen. I have given the arrow in one direction, but it is a bidirectional arrow. Now let us go back and then see. the network layer functions in CPS. So what is the purpose of network layer is that routing and forwarding. You know the difference between routing and then forwarding, right? The routing is basically, it involves most of many systems from source to destination, and then you keep on this thing. I mean, send the packets to the source to the destination. Forwarding is nothing but if in the first figure, say for example, have a look at this figure. Yeah. So here I have a switch fabric, network fabric, right? So network fabric here encompasses ports. They are all called input port and then output port. If I have a fabric of say 8 port, eight port can be used for data dissemination. 1 or 2 ports can be input, right? Now, given this scenario, the forwarding is talking about input in the switch fabric to the output in the switch fabric. This is the communication happening in the switch fabric, right? So now for routing also you should calculate the path, the best path and optimal path. And then the forwarding within the switch fabric also you should calculate the best path. So in most of the cases, you always find or calculate or determine the best path for data packets to travel from the different nodes in the network. I mean, I'm talking about the CPS network. CPS network, now you would have definitely realized that it encompasses various sensor, actuators, and physical systems. Right. And addressing, you know that in normal conventional data communication, IP addresses are being used. And your assistant registrar sir was also talking about IP version 4, IP version 6. We are exhausting with IP version 4 and we are going with IP version 6, which is 128 bits. And each and every sand grain in the world can be assigned an IP address. Now, it is your thought process. When you connect an IoT device or when you connect an actuator or when you connect a sensor, what is the addressing mechanism that you are going to use? Whether it is an IP address or any other way, right? So the addressing scheme is again, a big topic. How do you give the addressing scheme to the IoT devices, Internet of Things, and industrial Internet of Things, and how these IP address will be communicating in terms of devices. It's a separate ball game altogether, but you need to know it's not as conventional the way we do for the normal data communication. It's a peculiar configuration system. Then another important aspect of the network layer is packet handling. So how do you handle the packet is again, as you know, those who are very good at data link layer and transport layer, okay, they will be knowing all this. Now, just give me one important call is coming. Okay, so this is how it is by managing encapsulation. The fragmentation of data packet is like, splitting the data frames into different sizes. The size should be handled by the network. The network I refer here is the CPS network. So this is the function of the network layer in CPS. And what are all the common protocols and then key protocols that are being used in the network layer is IP, Internet Protocol. Okay, and this is the foundation for routing, etc., etc. ICMP, people will take ICMP very lightly. People will take ICMP very lightly, but ICMP is very, very important protocol, and then it is used for debugging. In most of the cases, it is used for debugging and diagnostic error, etc., etc. So most of the algorithm uses internally the ICMP, and in CPS is also it is heavily used. And routing protocols, very popular, RIP, routing information protocol, OSPF, open shortest path first protocol. These protocol are also used in CPS as we use in data communication network, and here also it is being heavily used. And this protocol manages the routing of the data packets across the interconnected networks. And network layer functions, we'll spend some time here. The network layer in CPS is vulnerable to various attacks. This is the one of the layers which is vulnerable to the attacks. So the first one is routing attacks, because most of the cases if you use RIP, routing information protocol, you manipulate the tables, routing tables, and the routing tables are available in each and every intermediate nodes, and that is the first point of attack, right? So routing attack is very, very common, very, very predominant, and we should safeguard it. So manipulating the network routing tables to disturb the communication. As you know that routing table is very, very simple entry, source, destination, port number. That's it. You modify one of the entries and then you have a packet gone to moon. So that is where it is. And then flooding attack. Flooding attack in the sense that I keep on send packets over a flood. I mean, this thing. Yeah, somebody is raising the hand. Do I need to stop here for some purpose? Some of the participants, I mean, I think Tenmuri madam is raising her hand. Do I need to stop here for some this thing? Or maybe for attendance purpose, you are raising your hand, madam. Good. Okay. Then spoofing attack. Spoofing attack is impersonation. So the source is controlled by someone, and some of the intermediate node is acting as the source node, destination node, intermediate node. So you keep on, spoof, impersonate the nodes, and then the source and destination of the packet is changed, and then it is very, very common attack in the CPS systems. So let us see what is the CPS architecture and suitable for these kind of functions, right? So CPS, uses the layered structure. That's what we have seen. So the network layer is sitting in between the physical and then application layers. So the physical layer will have the sensor and actuators, and application layer will have the data processing and control mechanisms, right? Some of the examples of CPS network are like this. So the CPS network can, it can include various technologies for communication. I mean, examples. You can have the wireless and wired technologies. It can be used for, connecting different components and devices. And there is a machine-to-machine networks. Most of the manufacturing industry or high-scale manufacturing applications connects the machine via the wire or wireless, and this concept is called machine-to-machine network. So many machines are connected together to have one single machine, right? Even the software-defined vehicle can be treated as like that. Small machines are connected to have a bigger machine, that is a car. Okay, and then this will have a direct communication among those, the devices. Then IoT, cloud, and then edge networks, right? Okay. Now I have the physical layer. So before we discuss the physical layer, I'll show the physical layer once. So this is the physical layer. You saw the actuators, you saw the embedded system boards, Raspberry Pi or whatever it is, and there are a lot of sensors. Okay, a lot of sensors. Sensor is the one which sends the real world and give the analog data, and that data is being converted as a digital using digital to analog to digital converter, right? So now, as far as the physical layer is concerned, it is the part of the hardware, and you'll have the physical devices as I have shown in the picture. You will have so many sensors, so many actuators, so many controllers, and so many network interface cards, right? And the transmission medium can be anything. So I have shown you in my earlier picture, say for example, here firewire is a physical medium, USB 2 is a physical medium of communication, CF is medium of communication, UART is medium of communication protocol, all right? I2C is a protocol. Likewise, the physical layer is the one which handles so much of the different ball games. So the voltages, the network interface card, controllers, actuators. This fellow is real, the monster, without which, you cannot have anything at all. And the transmission medium, as I shown, it can be Ethernet, CAN bus. CAN bus is basically the one which is heavily used in hospitals, especially the medical, the network. Patient is being operated and the doctors are connected remotely. The data is propagating here and there. It's a live data and it should not be hampered even 0.0001 second, 1%. So this CAN bus is very, very popular and it is being used. And wireless, Wi-Fi, Bluetooth, Zigbee. Zigbee is very good protocol used in house automation. Wi-Fi, Bluetooth. We all use Bluetooth for the connecting headset, etc., etc. Signal encoding is very important. Those who are good at computer networks, or communications for the matter of fact, they will agree with me. If you are good at signal encoding, you can handle any CPS systems. Even I saw some of the questions, what is the encryption that is used in CPS? Encoding is different and encryption is different, but you have different encoding mechanisms to handle the data in single path. The peculiar example is that I told you in CBR, Central Building Research Institute, when I saw there are hundreds of sensors and the value of each and every sensor is sent by only one fiber using WDM. Okay, so that is how the encoding scheme is being used heavily, right? The 0 1s are being, and the 5G is the one which handles sensor from 1,000 sensor, millions of sensor it handles, but only one medium. But encryption encoding is different. Okay, that is the tune of the research work happening in encoding, signal encoding mechanisms. If you want to have any questions, you can push the questions in the text box. I'll be happy to answer this. Now, most of the communication networking and the computation in the what is that? The CPS is like this. So this is the typical CPS. It has multiple sensors, actuators, and controllers. You can see that. So there are a lot of controllers. There are a lot of controllers, and this is a macro level state awareness, and here micro level monitoring, here communication layer, and here sensor. So it is basically the physical layer, communication layer, then application layer. And see the way in which it is connected. it is a kind of, centipede. Okay, so all things are connected everywhere. All can access anything, right? So the macro level state awareness is a protocol similar to the application layer. The micro level is basically the physical layer. The communication network layer takes care of the intermediate business, right? So this will be a typical the structure of any of the CPS network with the communication, computation protocols, etc., etc. Right. So this is what I thought I will discuss with you guys, and thanks for the opportunities. Now I have given ample time for the interaction. I can take up the interaction if the panel members allow me to take it.
Thank you so much, sir, for the insightful and enriching session. We now open the floor for the participant queries. Kindly feel free to post your queries in the chat box or raise your hand to interact directly. Over to the participants. If you have any queries, you can post in the chat box or you can interact with the sir.
No questions? Surprise. Okay, there is one QR, this thing. Good
Sir,
morning.
some of the queries has been posted in the chat box, sir. Actually, you can have a look at it.
It is in the question and answer box, right?
Sir, shall I actually proceed, sir, with the questions?
Yeah.
In behalf of them? Yeah. Okay, sir. What kind of encryption is done in CPS?
Okay, yeah, it is asked by Divya. Yeah, Divya ma'am, CPS is basically, I think you are asking in terms of the cipher AES, DES, RSA kind of thing. In more, it encompasses everything, Divya ma'am. Actually, it is like this. Specific application based. Say you want to secure your keys, etc., then RSA. You want to have high-end encryption time and high-end decryption time, then you go for AES. And even if you go for AES, you go with the 256 as the key size. Likewise, it's not only one encryption mechanism that is being used in CPS. All the encryption mechanism is used depending upon the specific application, and then this thing, starting from AES to DES to RSA, etc. There is no kind of one encryption that is used, kind of. Second, next question, madam.
So next question is from Manjula ma'am. Her question is, what type of AL technology is used?
AL means what?
I don't answer. It must be AA, sir, maybe.
Will go to this thing. I will put as in Danner. That will put us in Danner. Some other question.
Yes, sir.
Any other?
Next one is, can you differentiate the flooding attack and DOS attack?
Yes. Flooding is basically you keep on send the packets over the network. I mean, the network will be flooded with a lot of this thing, so that there is a lot of congestion. If there is a congestion, then there is a delay. If there is a delay, then you don't get a response and the latency increases, right? And it is a cycle, so that your network, the entire network is not going to be used. But as far as DOS attack is concerned, people will select, say, for example, particular port. Say 8080 is a port, and then you don't want to give the 8080, I mean, the web service port, say, for example, to you want to attack that. So what will you do? You will keep on pump the request response to only the particular port, so that the service of that port is denied for others. Right? So flood is basically you make the entire network choking so that the congestion, etc., happens for the entire network. And as far as the denial of service is concerned, I will particularly attack a particular service so that it is not denied, it is denied to the others, not available to the legitimate users. That is the difference.
Okay, so thank you. Next one is like, can you explain the CAN protocol?
CAN protocol is a separate protocol used in. I told you, it is available. It is used heavily in hospitals, where the internal system is connected. All the devices that are participating in surgery and the ICU, say for example, all the ICU devices are connected in a bus, and then the entire bus is called CAN network, and then the protocol that is used for processing the request of the CAN network is the CAN protocol, especially for the hospitals, small infrastructure. It is used.
Okay, so next one is kindly explain CPS in our annex.
Avionics.
Must be.
Avionics. Yeah, avionics. Actually, I can this thing. My screen is visible, madam. Is my screen visible?
Yes, sir, it's visible, sir.
Yeah, avionics is basically talking about all the aerospace related equipments. Now, say for example, the flight simulator, you might be seeing the flight simulator everywhere. The flight training center, etc. Now, the CPS, say for example, the source and destination, it uses basically all the, the signal. I mean, there is a concept, say takeoff, cruise, landing. Now, all the aircrafts, the avionics, the helicopter, aircrafts, military vehicle, drones, all people uses the space when they fly. So if that is the case, now think of, avoiding the collusion between two, or making collusion between two with someone of the attackers. So what will happen is that it is the entire CPS system that handles whether the signal originated from an aircraft to the air traffic controller is original. I mean, it's not violated. And if there is an intrusion also, it is being detected. So avionics is the system where a lot of physical systems and engineering systems are available, and each and every system are manufactured with CPS aspects only, because you cannot have even 0.001 malfunction in avionics due to security this thing and all. So avionics is one of the industries where the CPS is pervasive. Every signal, every system, every engineering aspect is basically the CPS. All encryption, etc., is done like that. Very, very important CPS in APS. Madam?
Yes, sir. Next one is if we are using two algorithm, will be the time complexity more, how to deal with that. That is what from Dr. M. Saravanan. If
Two
we are using
algorithms?
two algorithm, so how about the time complexity? Will it affect time complexity in any way? That is what the question is about.
Yeah, say algorithm time complexity is fine, and in general, CPS systems, the time complexity is matter only when you go for the real-time scenarios, and if you go for some of the time delayed applications, etc., time complexity is not at all an issue. Of course, I mean, that is how, people talk about the optimization, right? So when I have a CPS device, say, for example, and then I say that the CPS device is optimal, this is optimal in terms of computation, it is optimal in terms of communication, it is optimal in terms of many things, means that put together all processes evaluated in terms of algorithm, if it is a real time, I will optimize such that two algorithms should be compared in terms of the time complexity. Yes.
Yes, sir. Thank you. Next one is any online tools available like SHA-1 online calculator?
Is it?
Is any online tools available like SHA-1 online calculator?
Online calculator. Online calculator for what?
So that's what the question is about, like SHA-1. That's what they have sent.
We'll skip this. We'll skip this, madam. I mean, calculator,
Okay,
I do not know.
yeah, okay,
Yeah.
sir. Okay, sir. The next one is in a drone. What kind of encryption are you using, sir? In drone.
Yeah. Actually, we always send this, the communication over 2.4 gigahertz. In general, for the research purpose, we use the naked signal only. But if you really want to hide the signal, in general we go for kind of multiplexing, and the DES kind of thing is important. Yeah, DES kind of thing.
Okay, sir. I think that would be helpful for the participants. So now we formally conclude the day's proceedings. Now I invite Mr. Amit, sir, Assistant Professor, to deliver the vote of thanks. Thank you so much, sir, for your patience and taking the time for answering the questions. Thank you, sir. I am inviting Mr. Amit, sir, to conclude. Thank you.
Good morning, everyone. On behalf of our organizing committee, I take immense pleasure in delivering the vote of thanks for day 2 of our 5-day virtual faculty development program on cyber physical systems. I would like to express our gratitude to the speaker, Dr.A.Vadivel, for his insightful and engaging session on communication and networking in CPS. Sir, your presentation has laid a strong foundation for the rest of the program, offering a comprehensive overview of the key concepts and real-world relevance of cyber physical systems. Thank you, sir, for your valuable time and contribution. We are also deeply grateful to our Honorable President, Engineer ACS Arun Kumar sir, for his continuous support and visionary leadership, which has been a constant source of encouragement for all our academic endeavors. Our sincere appreciation goes to our Vice Chancellor Dr. S. Geeta Lakshmi Ma'am, Registrar Dr. C.B. Palanivel Sir, Additional Registrar Dr.V.Cyril Raj Sir, Advisor Dr. Mehta Sir, and Dean of Engineering and Technology Dr. Ithiraj Sir for their continuous support and guidance in organizing this FDP. A special thanks to our Head of the Department, Dr.N.Kanya ma'am, for her dynamic leadership and encouragement, and to all my dedicated colleagues whose teamwork and planning have ensured the smooth execution of today's event. Last but not least, I extend my heartfelt thanks to all the participants who join us today. Your presence has made this event a truly interactive and enriching experience. We look forward to welcoming you for the upcoming sessions in the coming days. Thank you. Have a great day, sir.
Shall I leave, madam? Is it fine?
Yes, sir. So thank you so much, sir. Thank you so much for
Thanks,
taking
ma'am.
your time and enlightening us. Thank you so much, sir.
Thanks.
Dear participants, for your information, the attendance link will be posted in the chat box, so you can log in and you can give your attendance immediately. Within 20 minutes, you have to finish off your attendance. Thank you.